Hey guys, my name's Mike. Thanks a lot for coming to the talk and for hosting the conference. I appreciate it a lot. So what I'm going to talk to you guys about today is testing Python apps with third-party integrations. And then afterwards, during lunch, I would love to collect stories about it. So I'm going to present stories about kind of what happens when you screw this up. Some of them are mine and some of them are other people. But if you have a story about screwing up a third-party integration, I would love to know during lunch, so let me know. A quick show of hands just to see in the room how many people are working with APIs. How many of you guys are working with Django on a semi-regular basis? Okay, more than half the room. And how many of you guys are working with Flask on a semi-regular basis? Okay, a fair bit of, fair number of people as well. So this will be especially pertinent for you. And the super exciting thing is we were going to demo an open source library that we're building. It took us a little longer than anticipated to make it, and my colleague just pushed the final things to master 1 minute ago, so you guys will be the first ones to see it, which means you can make pull requests during the talk if you find any bugs. So without further ado, yeah. So during this talk, we have we made a Gitter. I don't know if you guys have used Gitter before. Let me open it up. We have a pretty nice sized community of people in there talking about this tool called Unmock that we're building. So you guys should definitely pay attention to me unless you're on our Gitter, in which case you're free to ignore me. So it's gitter.im/unmock/community. So definitely feel free to go there on your phone, join, say hi to the other people that are there right now. There's people from all over the world. And then this slide list, these slides are on this bit.ly, and I'll have it several times. I gave this talk once and accidentally had write access enabled on my slides, which was, that was interesting, what the person did during that talk. So, but now it's read only, so yeah. So first I'd like to talk about the 90s. Show of hands, because this depresses me sometimes. Who here was not alive yet in the 90s? Oh my God. Yeah. That's tough. So yeah, I'll tell you what it was like. That's what this is going to be like. So that's Oasis in the middle, who was super popular for a week where I'm from in America, and maybe in Britain for a little longer. I'm sorry if one of you guys was in Oasis. I don't mean to be diminutive to your band, but that was big at the time. Java was just launched as a programming language, as kind of this enterprise language of the future, and Bill Clinton was president of my country, the United States. Welcome to 1995 specifically. That's a pretty big year. All these pictures were taken from the great year 1995 when I was 13 years old. So in case you weren't writing code then, which is also when I started writing code, error handling was a mess. So errors would happen all the time, but there was kind of no convenient way to handle them aside from just services going down, like AOL. It took an army of developers to write authentication code, so everybody wrote, there's no OAuth that didn't exist, so everybody wrote their own authentication code. No APIs really to speak of at all, so basically the only APIs that existed were de facto ones within a giant monolithic repo, but people didn't really consider them as such, and definitely REST was a PhD dissertation that came out during that decade, if not the early 2000s, I forget exactly when, but definitely not in the culture. And then no Git to speak of really yet. So Linux kernel of course existed, but Git is a different monster. So when you would have an error, you would have Netscape showing. How many of you guys remember that screen? Oh, that makes me feel better. Okay, so I'm not that old. It's in Netscape, eBay had this logo, and then that's not me, but that's somebody in 1995 doing their thing. So then fast forward to 2019. eBay, there's GIFs in 2019, and eBay's logo is now a GIF, which is, I thought it was cool to put it into the slide until I was prepping it and had to look at it all the time, and it's kind of freaky to look at. Yeah, it's super annoying, so I'll get off of this slide really quick. Sorry if you work for eBay and I just said that, but there's lots of services to handle these things, so let's go back and make a comparison. So error handling is a mess. Now, how many of you guys use Sentry.io? So Kramer, the CEO of Sentry.io, is a big Pythonista and made it originally in Python, and now it covers a lot of different languages and stuff. But it can do error handling, no problem. How many of you guys use Auth0? Okay, less. How many use Okta? More. Okay. So Okta is and Auth0 are both authentication solutions. So you get like authentication of the service. And eBay now has over 20 APIs in the flashing logo. So it's the difference between the two is that it used to be that none of this stuff existed or you had to make it yourself, and now we buy all of these things as a service from usually other providers, which means that our own code base is a lot smaller. So that means if there's a service that you're buying, then what you're consuming, you're all consumers of APIs, and if you're working with Django and Flask, you're also producers of APIs. But today I'm going to be talking about consumption. So fun times with APIs, and this is kind of when story time began. So let's talk about why we write tests. How many of you guys have seen this meme before? Okay, very few, great, so the joke's not stale. So, oh no, the robots are killing us, that's like terrible, like who wants that, right? And then, but why? We programmed them never to do this. And then you see static bool is crazy murdering robot equals false. Interact with humans. If crazy murdering robot equals true, kill human. So in C code, it's because they don't use the double equal sign, so it winds up being assignment. And then I'm pretty sure that when the robot apocalypse comes, it's going to be because of that. But luckily it'll be done in C, not in Python. So you guys have clear conscience, so no problem, because you can't make that mistake in Python. You can make a lot more though, but not that much. So this is why we test things, and why we test APIs, which is what this is about, and that what we test when we're testing third-party APIs. So a lot of times people want to split functions into services and isolated contexts and interfaces and use injection of dependencies and follow all these Uncle Bob rules about how to write good code. That's like in theory. In practice, this is copied out of one of our initial microservices that we wrote in my company. Like, you have a definition, and inside of it you have 3 requests to an API, which is like the word, I mean, putting 3 API calls in a function with like no try-catch block or something, it's like code suicide. It's like playing Russian roulette. It'll fail 1 time out of 10. But we wrote it, so these are the types of functions that exist in legacy code bases, and this tends to be the type of thing that you're testing. So it's really hard to test something like this because there's so many dependencies. It depends on HubSpot existing, it depends on Stripe existing, SendGrid existing. So like, how do you test a function like this? It's really, really hard. So what I'm going to talk about are ways that I have personally failed in testing it, and maybe you will recognize yourself in it. If not, you're a far better Python developer than I am. Actually, one thing before that. So to learn about a bunch of APIs that exist, small plug, there's this thing called programmable web. So if you're not using a lot of APIs or consuming them yet, there tends to be an API for everything, and programmable web can hook you up with them. So bad option 1 about working with tests is doing nothing. That's like, I've gotten insanely high code coverage in my repos by disabling tests. So the test doesn't pass, so you disable them. That is kind of one way to deal with tests that don't work, but not recommended. And when I shave my beard, I actually look like Borat. So like sometimes if I have a mustache, I can even like do the pose. And depending on how wild the party gets tonight, I might be doing exactly that. So number 2 is using the real APIs. So this is my favorite part of the talk, and these are the stories that I'll be collecting from you. The one in the bottom left corner came from like a recent Python talk that I just did. So if you use the real APIs in your test, stuff like this can happen. So 1, error no such user. So we had a company that I was doing consulting for, and they ordered a data science study on their users of just kind of certain aspects of user behavior, but had no test, but they were doing unsupervised learning. Have you guys heard the term unsupervised learning? So looking for similarities within data structures, in this case it was JSON, to prove a hypothesis that users kind of had similar type of behavior, even if they came on a certain website at different times of the day. And if that was the case, then they were going to cut out a lot of features. Essentially, they were maintaining a lot of features depending on if you came in morning and night, but they were like, actually, this doesn't matter because everybody does the same thing, no matter what. So they were looking for self-similarity in patterns in JSON. So they set it up, no test, they run it, and they're starting to run the unsupervised learning regression over time on the JSON, which is stored to S3 in S3 bucket. They're running it, and they look that they're getting like self-similarity metrics of all the different usages that are close to like 99%. So like this regression is showing that everybody has the same behavior, and they're like, wow, we're going to be able to save so much money, we can cut out all these features without looking at what the data was. So then the consultant, like not me, somebody else, comes to like present what these similar features are. And the similar feature of all the JSON that this person collected was they all had a field called error no such user. And that's after running it in production for two months. So what happened was that the person didn't validate or put a valid API token and then didn't actually check to see the data that was being collected into S3. So of course it's all going to be really similar, and like that's a lot of money down the drain for nothing. My favorite one, which is one of the reasons so I'm the CEO of my company, and one of the reasons that I started it was this story, which like I absolutely love, that a company accidentally embedded a Twilio live API key in their testing environment, in their CI environment, and then one of the engineers coded a number, like just kind of a fake number, was +1, like an American number that they didn't think existed, totally existed. So the CI environment was sending 10 times a day a text message, "I want you back," with a little heart, to some dude in Kansas. And that's great. I would love to get that text message 10 times a day, but maybe this guy didn't. So he actually called. He went through this whole process to figure out who was sending it to him. And apparently it's this guy named Jenkins who really wants him back 10 times a day. So that can happen if you put your production credential sending Twilio. Then too much swagger. So this is a recent one, and kind of the names and faces have been changed to protect the innocent, but some of you might recognize yourselves in this. I certainly do. So a costly internal project was canned because not really my team's Swagger spec and my API implementation grew hopelessly far apart. So a Swagger is a way that you can specify APIs. There's other ways too, like RAML if you're using what's it called, MuleSoft. But Swagger is a great way to specify APIs, and some people auto-generate APIs from Swagger documentation, and some people just use it for documentation. Both are great. If you're using it just for documentation, that means that your APIs conform to the spec, and if it doesn't, then it gets pretty wild. So they were publishing their Swagger spec, and then people would like use that in order to compose API requests, which is natural, and when they would do it in Postman or curl or whatever, it just simply wouldn't work. So they actually had to pull the spec, which is pretty bad, meaning that they had given documentation to developers and they took it away because it was actually more expensive to have bad documentation out there than no documentation at all. So that was pretty unfortunate. And then this is great. So a testing engineer created a username called or1=1. So I'll explain what that means. That actually got sent repeatedly to a production API in a CI environment, and they got banned permanently from using the service. So does anybody recognize or1=1? You bad people. So what that is called an SQL injection. So if you're writing SQL and you have like delete user if name equals Bob, and then you attach or1=1 to the end of it, then we'll always delete the user, because 1 always equals 1. So the condition will always be true. So that's called the SQL injection, which is really popular and maybe still is. I'm not sure, but the person created it as a joke, or username or1=1, except it was actually being sent to a production environment, got flagged as an SQL injection, and then this company got permanently banned from the service in spite of like being begged to let back, and it was a pretty important service for them in their stack. So all of these are the bad things that could happen when you're running tests using real APIs. So bad options 3 is the happy path, where you just reverse engineer the case where the API works, essentially. So what that's doing here is you are writing a test that just confirms that you called a given URL, and you say, great, everything's fine, because I called that URL, and if it messes up, that's their problem. And it's true, there's a separation of work and development. So if HubSpot screws up, it's their problem for screwing up, but then it becomes your problem because there's a 404 or there's something that you have to handle gracefully on your side. So it doesn't, you can't just kind of wash your hands of it and say, I'm going to test like when stuff goes right, because if the external vendor goes wrong, like I'm immune to blame. It unfortunately doesn't work that way, even though we might want it to the contrary. So that's another bad option. And the last one is this one of reverse engineering the APIs. I actually had a colleague in a previous job that we were doing Facebook integrations, and the person reverse engineered a mini version of Facebook just to test out the integrations, which was like pretty awesome. Like they like use the CSS from the site and everything. So like I don't know if you guys have ever been pulled into like a hole like this, but like, you know, somebody says like, oh, why are you working so hard on this thing that like is not adding that much value? And it's like, well, I did this, which assembles a Haskell function for parsing HTML. So when you wind up reverse engineering APIs, like it's kind of like eating potato chips. Like it starts out as this like innocent, I'll unlock 2 or 3 Facebook methods. We'll actually use our authentication too. And then pretty soon you've rebuilt Facebook, which is awesome because you'll make a lot of money and have a unicorn, but it's pretty bad for your company because you won't necessarily be providing business value to them. So these are all what I consider to be bad options for working with APIs that you consume. So it would be like pretty mean of me if I came and only gave you guys like bad options. But I've seen all of these either in my current setting or in previous settings. So if anything, I'm saying this to let you know that you're not alone. Meaning if you identify yourself in all 4 of these, I do as well. And they're mistakes that I've made when testing APIs. And I would say that from my work, because this is kind of my job now to help people out with this, the one that's most common is this. So you write a test and you just disable it. In PyTest, you guys can do like test.skip, or you can use an annotation to disable it, and you'll say, okay, when I get around to actually being able to mock this API, I'll like run this test. And then you have a lot of tests that are skipped, which looks at everything passes until it doesn't. So I'm going to talk about 3 projects right now that you can use to help you out with this. There are different stages of kind of maturity and development. And as I mentioned, the one that we are working on just got pushed to master 15 minutes ago. So there you go. So Act 3, I'm going to talk about Pook, which is a GitHub repo that I've actually prepared a small repo for you guys. So if any of you guys want to clone it, unlock Python demo, it might actually be broken because I don't know if I've pushed it to production. Anyway, it exists. It's just like it might fail. But if you run it, do the pip install and then PyTest. So this acts kind of as a spec for Pook. It can help you guys learn and use it more effectively. So the way that it works, this is not going to be too much of a read the docs type presentation, but I do kind of want to show you guys what's going on in it. So actually I could just open my IDE. Yeah. So what you wind up doing in it, by the way, it uses a lot of libraries that are, somebody should, are any of you guys participating in Hacktoberfest? Okay, great, thank you. So this library has a lot of APIs that are going to be deprecated in 3.8, so whenever you run it, you get like crazy warning messages all the time. So that'd be like a nice contribution to this library. What you do is you say that when I call this, so Behance is a design API, so you specify when I call this API, I want to reply with 200 with the following headers, and these are headers that actually come from like Behance that I just like copied and pasted into a fixture. There you go. And then when you write your test, you could do request.get Behance, and then you assert that it's 200. So I'm kind of not practicing what I'm preaching because this is one of those happy pass tests, right? We said in Pook, we defined that we're going to call this API, and we wanted to reply 200 with these headers. And then all we're doing in the test is calling request and asserting that it was 200. So basically, this test proves that we've correctly reverse engineered the API, but it doesn't actually show the business logic of like our application. But I just want to show how easy it is in something like Pook to like drop in a URL, headers, and say, okay, you should respond with a response. By the way, clicking through this Behance project's response that you're responding with, I just copied and pasted some JSON from Behance. So it's like a fixture, and it just serves it back, and this is like a pretty common JSON that you would get back from Behance. So you could do that. Then you can also do it on a local server. So you can capture, actually this is not a local server, sorry, this is still a remote server, but called server.com. You could make an inline request, and because Pook can be activated with a annotation, it can be on a per test method, and that's really useful if you want to make some real API calls. Like let's say, for example, you're using Kubernetes and you have a microservice environment spun up while you're doing your testing, or you're using Docker Compose. You might want to call localhost because you're emulating some type of microservice on localhost with using Docker, but if you're calling something that's external, you might want Pook only to intercept that, and you could do that with an annotation, and then just say, hey, when I call a get request to server.com, reply with 204, and not surprisingly, you could then assert that you got 204 back. Again, this is kind of a trivial example because you're just asserting that you get back the thing that you define, but it just goes to show how easy it is to work with something like Pook to make a basic mock without like totally reverse engineering the API. So that is Pook. The next one I'd like to tell you about, which is a bit more popular, is called HTTP Pretty. How many of you guys are using this? Okay, so more. There were like between 0 and 1. Like I have pretty bad eyesight, so it was either like the light or somebody's hand going up for Pook, and there were like at least 2 for HTTP Pretty. So HTTP Pretty is a library that's like Pook, but uses a lot of conventions from Ruby, essentially, so from Ruby testing libraries. That ecosystem is a little bit more mature than the Python one, so it was imported from that. It's basically a clone of a Ruby project, but it works really well in Ruby, and it also works quite well in Python. So the first thing that you have to do is you activate it, and you register a URI, so this is not that different than Pook. So we say it's going to be a get method, and when I call http.org, this thing, I need to reply with this body, which is JSON. There you go. So this test does exactly what we saw in Pook. You're calling requests, and then you assert that the JSON should equal what you said you'd serve back. So it's not that different than Pook at the end of the day. They have like pretty similar dynamics. It's just that I think that the syntax of this is a little bit more elegant because it's a composable syntax. So like, for example, you can put all sorts of keys, like status 200, content type text JSON, adding headers, add this. And you can kind of add on to it and then disable these things. So one really nice thing that we do in my company is we store all of that in a KW args and then just * whenever we need to destructure it in some type of test. And then you can just manipulate the KW args. Like you see that this is a 500 and this is a 200. So in our KW args dictionary, we can just replace status from 200 to 500, and then we have another test that tests something breaking. So that's like a really nice API that HTTP Pretty has provided, and that comes from the Ruby world as well. So of course, because I'm going to present our tool third, I will recommend that you guys use it even in its like hopelessly broken new state. But that said, if you don't use ours, and I will totally understand it, HTTP Pretty is an excellent way to mock API traffic really fast without accidentally reverse engineering an API. And now, if I haven't already beat it over your head enough, coming up is Unlock, which is what we're working on. And what we're trying to do is something a little bit different. So what you've seen before is that you always define in HTTP Pretty or in Pook static responses. So you're saying whenever I call foo.bar.com/users, send me back this thing, and this thing's never going to change. And that kind of makes sense, because when we run a test, we want the test to be repeatable. We don't want it to like succeed on our CI server once and then fail the next time because we're changing the output. So those are called fixtures. Why? Because they're fixed. You use them only once. So here, our goal is to do something a little bit different. Fuzz testing using functional programming. Fuzz testing APIs in Python using functional programming. So there's kind of two terms in there. Sorry that I put FP. I meant to like, that's like super conceited to assume that. Like, that's my personal abbreviation for functional programming. It could also be a lot of things, I guess, FP, so I'm sorry about that. I just forgot to like expand it out. So API fuzz testing. So what is fuzz testing? How many of you guys have heard the term before, fuzz testing? Okay, so about a third of you guys. Fuzz testing is when you don't exactly know the behavior of the thing under the test, so you just do it many, many times. If any of you guys are coming from the Haskell world, there's Quick Check. From the JavaScript world, there's Fast Check, and those are property-based testing libraries that do a similar thing. They run the test, except instead of running it once, you run it 100 times, and you run it 100 times with slightly different variations on like the input or the variables or something. And then after you've run it 100 times, you could deem, okay, if there's a bug somewhere in this code, I have the confidence that I've run it 100 times, and I've kind of tested out all the corner cases. So that's what's called fuzzing. So my personal belief is that fuzz testing, when you're working with third-party APIs, is a much better idea than serving static fixtures. Why? Because when was the last time that you worked with a third-party API and got back the same exact response every single time? The silence is deafening. Not like I thought anybody was going to say, me, I do that all the time. But that's the reality of it, is that when you're working with APIs, you're going to get back dynamic responses all the time. So it will dynamically trigger a certain type of bug if the response looks a certain way. A classic one would be that a user's list returns 0, but you assume that there would be a certain number of users in it, or a field that you're assuming would be in JSON is not there, and you're counting on it in some type of function. So those types of bugs can only be seen if what you get back from the API provokes that bug. So it would stand to reason that instead of using a fixture in API testing, that we would do fuzz testing, meaning we would do it 20 times or 100 times with slightly different input. Except you're not going to do that manually, meaning you're not going to call an external API 100 times, save it 100 times, and then serve back that fixture 100 times. I mean, you could, but it would be like a pretty sad use of your time. And like life is short, and there's other things to do, like watch TV and drink coffee. So like you want something that's going to be able to do it for you. And what we've implemented in JavaScript is something that does fuzz testing for APIs. So I'll show that briefly. The testing API integrations by creating effective simulations of APIs and microservices, and basically, like I won't get that much into this because this is like not a Python library. Yeah, so it's going to the homepage. But the basic idea is that it generates like a random number and a random string. So this is exactly like the poop syntax that we saw before, except instead of saying that the number is 1 and the string is like foo, it says, okay, every time do like a random number, random string, and then there's a runner that just runs that 100 times with different random numbers and different random strings. So that's kind of what fuzz testing in API land is. And so github.com/unmock, we just like literally pushed a Python version of unmock, who's built this thing. So there you go. But has 94% code coverage of a failing build. So like the philosophical question, which is better or which is worse, but public API mocking for Python. So we don't have fuzz testing yet in it, but we've built all the infrastructure for it. So the last little bit of this talk, in my last 3 minutes, is a call to action for you guys. So I was talking to a few developers from Thorgate who are in the room. I see some of them right now, about potentially helping out with contributions to the Python version of the library. We have a couple Pythonistas in the community, myself included. Also one of the employees of my company, Idan, who's responsible for the breaking build. I hope you're not watching right now if there's like a live stream, has also worked like a lot on it, and he's done like a great job. So we maintain it because we are greedy capitalists, and our company's business is helping people better interact with APIs. So we do consulting for companies that build APIs. So we think that if we have awesome developer tooling for APIs that's out there and free, people will be able to use it, learn more about how to effectively test APIs, and then if they have a really complex case, call us in to help them out with that a little bit. But we also maintain it because like it's a employee-owned company, and we all of us have like stake in it, which means we can all kind of decide what we want, and we absolutely love open source. So my first open source project, which is a GNU project called LilyPond, which is a music typesetter, has tons of Python code in it, and I was one of the maintainers of that. So I personally enjoy being the maintainer of open source libraries, and I would love to maintain an open source, non-broken version of Unlock in Python. So that's my call to action. If anybody thinks that the idea of fuzz testing APIs is pretty cool, definitely talk to me during lunch, because we have a whole issue tracker, the first of which being fix that build that you saw on GitHub. And if you don't think it's cool, I'd still love to talk with you about how you guys are working with APIs. So thank you very much.
Great, perfect. Let's get to the questions. So, from your panel, Gitter, Slack, and Teams, why so many?
Yeah, so several reasons. One is that MS Teams, we migrated to it recently. I hope I didn't break GDPR stuff in there. I hope that there weren't any like notifications of users, but assuming that there weren't. Yeah, so Gitter, because it's open, because it's referenceable, so you can give a link to any Gitter chat, and it will say like what's going on. So we use that for all our open source projects. Slack, it's because our accountant will only communicate with us on Slack. And Teams is for like our internal company chat of like, hey, I'm late to work today, or my kid's sick, or like, did you see this awesome cat video? So that's my service.
How to work with a third-party integration in local testing environment when the third party only has a live environment without building your own?
Facebook, yeah. So the good question. I mean, the way that my company does. So we are a professional services company, and we provide a service to do exactly that. And what that service is we record live HTTP traffic, and then we use natural language processing methods like. How many of you guys have used something called random forest? Okay, so about a third of the room. It's a decision tree method that essentially creates this like giant arboreal structure of potential decisions and then kind of whittles them down over time. So we use random forest on requests and responses, JSON requests and responses to analyze like a million responses and say, okay, is this field called first name a first name? And like it will kind of look through all the different permutations to say, okay, generally this thing is a first name. It tends to be more complicated than that. So, but we record the production environment and then reverse engineer it using machine learning. So I know it's a big word, but it's just natural language processing, random forest, and also we use RNN, so LSTMs, to do that while monitoring the third-party environment. So that's what we do. That's our business. That's how we make money. But that's kind of not what this particular problem is.
Cool. Can you repeat a run with same data with unmock fuzzy?
Yep. So we have this super new, kind of undocumented feature, but we have a fantastic team member of mine who's somewhere in the audience who's like a documentation ninja, so hopefully that will fix itself at a certain point. But yeah, so it has output results, and the nice thing about that is that every test that you run, it will show what went into the runner and what came out. This is all green because like I'm such an awesome developer that my test always passed, but let's say that like it weren't, they'd be red, and then once it's red, you can see the red one, copy that, and then that's your fixture to be able to write a test just for the failing result.
Cool, amazing. Okay, what's the worst public and widely used API you've encountered?
What's the worst public and widely? Oh man. I'm not going to answer that. I want to say worse. Well, okay, yeah. I mean, worse because it's not nice. 1 second, let me find it. So, fuck off as a service is an API. That's not nice. Like, it's a modern RESTful scalable solution, common problem of telling people to fuck off. So it's actually an excellent service, but like, I mean, it's broken and stable. I've used it before, but like, that's not a nice thing to do to people. So that's my answer to that question. But yeah.
Okay, is unmock available for other language apart from JS or Python? If not, then any well-known equivalent?
Yeah, there's well-known equivalent for fuzz testing, no, but stuff like HT Pretty and Pook, yeah, there's a lot of it. There's basically every language has one of them, and they're all like great projects.
Does unmock also automatically minimize the failing test case?
No, and this is a super hard thing to do. So to minimize the failing test case, which means kind of to shrink basically to say, okay, like it's these 3 numbers that will like fail your thing, and everything else is fine. So to shrink it down to that, you have to use something called a shrinker, which is really common in property-based testing. But to use a shrinker, all of the random generation needs to kind of happen at one time, because if you have random generation that's out of control, then you can't shrink it, because then there's a fire here that you need to deal with and a fire there. And using a shrinker is really tough with API testing, precisely because the API is outside of your environment. So I'll give you an example. Let's say that you have an API test in unmock that returns a list of 10 users, and then you have a GET request for each user to get more information about them. That's a total of 11 requests, meaning your array is the first one, and then those 10 users are the next 10, so 11 requests. The next time you run the test, if it returns an array of 100 users, then that will be 101 requests. So controlling all of that randomness in one environment is really, really hard. So unfortunately, I'm not saying that you can't do it, and if you can, please come work for us with us. But making a shrinker is really, really hard for this type of testing. Yeah.
Does unmock support image responses? What types are supported with unmock?
So currently it supports arbitrary things. So I mean, because you set the type, you set the MIME type in the header. So if you want it to be JSON, it's JSON. If you want it to be multi-part form, it's that. It's arbitrary, so you can even make up your own types if you want. So it'll do images as well. Yeah. How different? Oh, sorry. I don't know if
Yeah, sorry.
yeah.
Yes. How different is fuzz testing from quick check?
Yeah. So fuzz testing is stochastic, meaning that it doesn't. So what we're doing is fuzz testing because we kind of test boundaries. So we test like an array of 0, an undefined array, a really long array, but we're kind of testing the boundaries of like what's possible. Whereas quick check, which is the Haskell like grandmother of property-based testing, controls all the randomness and has a shrinker inside of it. So we don't have a shrinker, we just kind of try to do the most outlandish things that'll provoke a bug, whereas this does a much more like refined, methodical shrinking approach.
Great, thank you for an amazing talk and thank you for your